Alright guys, so let's start off by opening up our TWIDO program. Once this guy opens up, then we're going to go over here to the programming mode. And we're going to create a new project. Okay, you're going to give this guy a name that works for you. I'm going to call mine 4 to 20 milliamps to the PLC. And I got WC just as my working copy. Okay, hit the create. And the next thing we're going to do is we're going to come up here to describe. And we've got to tell the program which PLC we're actually working with. So we're going to go to bases, compact, scrolling down to TWDLCAE 40DRF. Oh, that didn't work. So it looks like we have to bring this all the way over to the left. Nice, there we go. So that's our actual PLC that matches with the physical PLC that we'll be talking to. Next we have to do our expansion module for our analog inputs and outputs. And if we scroll down here, then we're going to use the TM2AMM6HT. So grab that guy, bring it over and drop it onto the page. Right on, looking good. Okay, next thing we're going to do is we're going to do our IP configuration. So we're going to do a configured IP. And you're going to match this IP exactly to the Lamicoid that's on your PLC station. Otherwise, you're going to be talking to another PLC in the lab. My PLC was 192.168.1.131. If I click on each of these guys, subnet mask and gateway address, they come in right away. So we need IP, subnet mask, and gateway, and we're good to go. Okay, next thing we're going to do is come up to preferences. Whoops. And we'll drop down here. At the bottom of the page, we want to make sure that that IP matches exactly with the value that we put in on the previous page. Okay, if everything's good, then hit apply and move on. And the next thing we're going to do is we're going to configure our analog inputs and outputs. So we're making use of a word for our analog input. So I'm going to put analog input. Whoops, what happened there? Let's try that again. All right, analog input current. Okay, we're making use of a 4 to 20 milliamp signal from our ultrasonic sensor. So we're going to choose 4 to 20 right here. And the scope, we're going to change the scope here from normal to a customized range. I'm going to go from 0 to 10,000. If you've seen the previous video that I did 400 to 2,000 because I really didn't know what I was doing. This value matches and will help us out later on when we do our PID loop. Okay, next thing we're going to do is our analog output. But rather than a current out, we're going to do a voltage out because the pump that we're making use of, the DC drive, takes a 0 to 5 volt signal. So we only have 0 to 10 as an available voltage. So we'll do a customized range here again. We'll do 0 to 10,000, and then we'll have to do a little bit of math in our PLC program to change that 0 to 10 volts to a 0 to 5 out. Once those guys are good, then hit apply. And the next thing we're going to do is we're going to go into the programming mode. Okay, so now that we're in the programming mode here, we're going to add a section. And when we add a section that drops a rung onto the page, we're going to grab one of these compare blocks and drop it onto that first rung there. When I see green, then I can let it go. And I'm going to take a look at that analog input current value. So that was a word value, that was IW 1.0. And it's a value between 0 and 10,000. So I'm going to say, all right, if it's greater than 0, greater than or equal than 0, then I want the first light to turn on. Not only that, let's make this a little bit bigger so we can see what's going on. Come on, there we go. Okay, not only that, I want to put in a little bit more of a range here. So I want to go from 0 to 2,500. So again, I'm looking at that first word. That's my analog input. And we'll say if it's less than 2,500, right, which is 25% of our 10,000, then we're going to turn on our first light. So we'll grab an output. They call this a coil, but that's our output. And our output is starting from 0, so we'll do %Q0.0 and hit enter. Right on. Looks good, guys. Now we're going to copy and paste this bad boy because we're going to put the exact same instruction in 4 times. Okay, now that those guys are in, now we can change our ranges now. So again, if we are greater than or equal to 2500, so 25% to 50%, so 50% being 5,000 out of a 10,000 range, and we'll turn on our next light, so Q0.1. Okay, now we're going from 5,000, so greater than or equal to 5,000, to 75%, so 7,500. Beauty, and we'll turn on the next light. Very nice. And for this guy, we're going to go from 7,500, so greater than or equal to 7,500. And I want to include the 10,000. So I put, that's good. And we'll put an equal sign there. Nope, come on, there we go. Beautiful, looks good. Okay, let's turn on that final output there. Nice. Okay, if we scroll down to the bottom here, we can analyze the program. So that's like compiling. And you'll notice that everything just turned green on the left-hand side. So we're good to go to download this to our PLC now. We want to save this project, so we can save it here, or you might find it easier just to save it right there. So anytime you're doing a lot of work, then just save it as you go. Let's put in some run comments here so that if anybody's looking at this, they can figure out exactly what we've done. So if the current's between 4 milliamps and 8 milliamps, then we're going to turn on our first light. So that range between 0 and 2500 is matching with our range of 4 to 8 milliamps on that signal coming in. Let's copy this guy and paste it in. Because we're essentially going to have the same run comment on each of these guys. And we'll just change the range again. I'm on the wrong one here. Let's go up here. There we go. So between 8 milliamps and 12 milliamps, turn on the second light. So the range of 2500 to 5000, or 25% to 50%, is matching with an 8 to 12 milliamp value. Alright, for this guy we're going to go from 12 to 16 milliamps, being from 50 to 75%. And then finally from 16 to 20 milliamps, we're going to turn on our fourth light. And that's essentially everything we need for this program. Let's compile this one more time, because we got that yellow on the side there. So we'll compile it one more time, or what they call analyze the program. Beauty, everything's green. It says no starts and the run was selected, but don't worry about that. And the next thing we'll do is we'll save, because we made a few changes there. And now we're ready to drop this into our PLC. So we're going to go to debug. Okay, so now that we're in the debug menu, we're going to make sure that this IP address right here, 192.168.1, in my case .131, matches with the Lamicoid that's in front of you. They're sequentially ordered, so we have computer, PLC, HMI, and then AC drive. Make sure that you're looking at the PLC IP address. Confirm that it's correct and hit OK to establish your communication. And mine already went through, but it's going to give you the option to either go from the computer to the PLC, or from the PLC to the computer. So go from the computer to the PLC and hit OK, and you should see your program come up like this. And the last thing we need to do is tell it to go into the run mode. So we're going to do that by hitting the play here. Takes a few seconds to come in. We're waiting for this to be green. Excellent. Now we're ready to rock now. Okay, so let's get this guy out of the way. This is a pain to get out of the way. You have to, I think, you right click on it and then bring it down. Yeah, it's a right click and then bring it down. You can also hit the X and it will disappear for you. Okay, so now, I mean, we can make this a little bit bigger. There we go. And let's just get this guy right out of the way. Come on. There we go. Okay, so we still have the same range. Let's see, 0 to 2500, 2500 to 5000, 5000 to 7500, and 7500 to 10,000. Right now, the current coming from my analog input from that ultrasonic sensor is now around 4 milliamps because it's in the lowest of the tank here. I'll do a picture-in-picture in a couple of seconds. But you can see here that the first light is on, so Q0.0 is on. And if you take a look at the front of your PLC, you'll notice that the green LED corresponding to input 0 has now gone green. Okay, the next thing we need to do is we need to use the pump, similar to when we were setting up or calibrating the analog sensor, or the ultrasonic sensor. Let's get the LV ProSim working, and then we can lift the level in the tank. So let's do that now. So we'll keep this running. We're going to go to our start menu here. Okay, so let's see. Let's bring up the start menu. Let's find LV ProSim. Here we go, right here. Okay, so we're going to click on this guy. Okay, so you may already have this going on your computer, but I'm just going to get it going on mine. So first thing we're going to do is hit continue. Then we're going to go to process, work with the trainer, hit continue, and then we're going to go to setup, enable communications, and you should see those LEDs chirping on your I/O box. And now what we're going to do is we're going to increase the voltage to our pump through this program. That's the only reason why we have this program on right now, is just to increase the voltage to the pump so we can increase the level in the tank. So we'll do that by putting this at a roughly 50%. And my tank is slowly increasing in level, so I'm now going to bring up my PLC program. I'm going to close my drain valve. My fill valve is open now. And once we get to 10 centimeters, we should see that a value starts to come in here corresponding to the 4 to 20 milliamp current. Let me just reduce the size here so I can do a picture-in-picture here. Okay, so we're just getting close to the there we go. There's our signal coming in corresponding to our 4 to 20 milliamps. And once we get between 8 and 12 milliamps, we should find that the next LED turns on. So it's slowly climbing there. You can see that value at 1800, 1900 now. Okay, as that level is slowly increasing, you'll see that the current on the meter is, there we go, increasing. Now we're at 2500, corresponding to a 8 milliamps, and now we're climbing to 12 milliamps. And once we get above the 12 milliamps, going towards our 75% range, then our third LED should turn on. So now the column of water is pushing down on the actual pump output. So I've now got to increase my pump output here so I can get it to actually rise. We're coming up, there's 30 centimeters. Ah, yes, and now we've got that third light on. Okay, we're going from 50 to 75. Once we get above 75, which is coming up right here, then the next light should turn on. Sweet, and then from here all the way to 50 centimeters, we'll have this final fourth light on. Once it gets close to 50 centimeters, then I'll stop it there by closing the fill valve. Yeah, so there's 50 centimeters right there, corresponding to our 20 milliamps on our meter. Okay, so let's see how this does on the way down now. We're at 19.99, we're at 50 centimeters. So we're just shy of 20 milliamps. My timing going up between the PLC program and videotaping the meter was a little bit off, so let me see if I could redeem myself on the way down here. So what I'm going to do is, because it's hard to videotape the screen get the pump going and get the meter all at the same time. So I tried to match it up, I didn't get it perfectly. So what we'll do now is we'll drop the level, and in dropping the level, all I have to do is just open up my drain valve. So I'm going to open that up now, and we'll see that the value is dropping, and you can see that on our PLC program as well. Now, see how the level isn't changing now? That's because I have an air bubble in my, my pipes. So what I'm going to do is I'm just going to lift my pipes up slightly just to get rid of that. There we go. Now the air bubble has been pushed out there. And once we get close to 40 centimeters, then I'll stop the drain valve. Beautiful. So at 40 centimeters, we should be having 16 milliamps. And on the PLC, we can see, see it's chirping back and forth now with that LED. You can't see it on the screen there. There you go. You can see it changing now. So let's drop it down just a touch there. There we go. And we'll make sure that that light stays on. The reason why the light was going back and forth was because the level was just hovering at 40 centimeters or at what, 7,500 on our PLC. Right now we're at 7424, corresponding to a current of 15.86, and we'll drop the level down again, and we should see at 30 centimeters that we get 12 milliamps. Beautiful. So there's 30 centimeters corresponding to our 12 milliamps, and what have we got on our PLC here? That looks good. 5,014 for the value coming in. So we're half of our 4 to 20 milliamp range. So we're half of the 0 to 10,000. Everything's mint. Okay, let's drop her down again to 20 centimeters. We should see 8 milliamps. Very nice. Okay, so we got what, 7.96? That's beautiful. And we should be at 2,500. We're at 2496. So we're now, it just jumped to the final LED there. So I'm a little bit shy of 20 centimeters. So I'm just jumped from the second light down to my first light. And from here all the way down to 10 centimeters, that first light should be on. Nice. So now we're at 10 centimeters, we got 4 milliamps, and the value on our PLC is 0, corresponding to the 0 to 10,000. Right on. So now what we've got is we've got a PLC program that you guys have now designed, and we've changed it. You may have done the previous portion where we're doing 400 to 2,000, but we've changed the range now from 0 to 10,000, so it'll correspond to what the TWIDO manual is telling us the range on our analog input should be in order to do the next step, getting closer and closer to a PID loop to control the level in the tank. But this is pretty cool, man. We've been able to increase the level in the tank here, so again we'll increase the level in the tank. We have a current that corresponds exactly to that level. We have a 0 to 10,000 range that's now turning on sequential lights. So now our second light turns on here. Beautiful. Going a little bit higher now, we're going to get to the 50%. Once we pass the 50% at 30 centimeters, then the third light will turn on right now. Gorgeous. And from there to 40, we're going up to 16 milliamps. And once we get above 16 milliamps, then our final light will turn on right about now. Gorgeous. And from here to 50, we're going to climb up to the 20 milliamps that we're going to have as a max. Sweet. All right, guys, no small feat there, man. You've got a PLC program that now matches with your 4 to 20 milliamp signal. You've got the sensor actually calibrated exactly with the level, You've now got a PLC program that's now giving you 4 different lights that correspond to 0, 25, 50, 75, and 100. That's awesome. The next thing we're going to do is we're now going to build up our HMI screen, and we're going to do some graphics and everything. So we're building up to a really cool situation where we're going to have the PLC program monitoring our 4 to 20 milliamps. We're going to have control with our HMI, and then finally at the end of all of these labs we're going to be doing a PID loop. Alright guys, thanks for your patience. We'll see you in the next video.